How did the ring galaxies get their weird shape? Could we redirect a comet to hit the moon? Could Project Orion ever launch? And in Q&A Plus, how badly did AI hit astronomy jobs? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are, across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Billions and billions of stars. Can we expect a meteor storm in our lifetime? Yeah, I think so. The last great meteor storm was, I think, back in the 1960s. So we are, say, 70 years since there was a big meteor storm. And a meteor storm, like a normal meteor shower, think about, say, the Perseids. You get about 60 meters per hour. The Geminids are pretty much the best meteor shower. You can get over 100, 120 meters an hour in a really good year. The reason we get these meteor showers is because the Earth is going through the trail of debris left from an asteroid or a comet that is orbiting around in the solar system. And so every time the comet comes around, it leaves this trail of particles, and then the trail of particles is pushed by the solar wind and slowly drifts. And astronomers know where each one of the pathways that the comet or the asteroid took when it made its flight. And so you can imagine there are these, I think of them like tubes, right? That there are these tubes which are all of the particles left over from the comet. And then the Earth is passing and can pass above them, below them. And every now and then the Earth passes right through one of these things. And if they're very fresh, if it was a comet that was giving off a lot of material, and we happen to pass through it shortly after it's given off all of that material, then you can get a meteor storm. And instead of you getting 100 an hour, you can get thousands of an hour, tens of thousands in an hour, 100,000 meteors in an hour. And you see these paintings or time-lapse photos that were taken during past meteor storms. And it is just like the sky is falling. It looks like some kind of science fiction thing where you've just got meteors just raining down in the sky. Like this would be, people always ask me, like, what's the thing that you would like to see in space? And I want to see a really nice, close, big comet. And I want to see a meteor storm. That would be absolutely incredible. But yeah, let's say they happen once a century. We could have one, but you never know. You might not have one for several centuries. So it's got to happen at some point. Cynic extraordinaire. If we disregard the geopolitical reasons why it probably would never happen, is the Project Orion idea of using nuclear explosions as propulsion a viable concept for achieving interstellar travel? So there's kind of two answers to this. Like, obviously, as you said, the geopolitical side of things, the realistic prospects of detonating nuclear weapons in the atmosphere of the Earth to accelerate a spacecraft is probably not that likely to get approval because, this is where we live. But if you were out in space and you were detonating nuclear weapons, then you would be able to impart a kick to a spacecraft. And the Project Orion is the result of a very famous paper where someone did the math and calculated what would happen. And the gist is that you are dropping nuclear bombs out the back of a spaceship, and you are timing it perfectly so that the thing explodes and is sort of the force is absorbed by a pusher plate on the back of the spacecraft. And then the spacecraft receives a push in the opposite direction and also ablates. And you get this thrust coming from the nuclear explosions as they are going off behind the spacecraft. And if you watched the Three Body Problem TV series and read the book, watch whatever, they cover this idea, sort of a mini version of this, where they have little nuclear bombs go off and they're trying to send a spacecraft out at relativistic velocities, and the spacecraft has to follow this trajectory of bombs that are going off to accelerate it. But I have seen plenty of takedowns on Project Orion. Obviously there's like a lot of moving parts. You have to store a whole bunch of nuclear weapons. You have to keep them working to be able to use this as a method of transportation. And that you kind of really want something that gives you more finesse And so that's why people are focusing on laser sails or antimatter as more realistic, or astrophage as a more realistic way to travel between star systems. Phobos Scorpio. If Jupiter could be turned into a red dwarf, could it be used to theoretically power a ring-world starship to explore the galaxy beyond with it as the solar generator? Whoa, that is some mega engineering that you are proposing here. So let's break this down bit by bit. So the first thing is, could you turn Jupiter into a red dwarf star? So Jupiter is 1/80th the mass that you would require to make a red dwarf star. So the minimum red dwarf star has 7.5% the mass of the sun. Any lower than that, and you just don't have enough mass for you to ignite fusion at the core of your star. So once you hit that minimum 7.5%, now you have a red dwarf star. And Jupiter is 1/80th, or like 1/77th the mass of the smallest possible red dwarf star. So the first thing you would need to do, if you really want to have that red dwarf star, is you need to find another 76, 77 Jupiters, right? Find those, crash them into Jupiter, and then you will have a star. It'll take a few million years, but it will turn into a star. So that's the first part of the problem. But you sound ambitious. I'm sure you can figure this out. So the second question is, could you then power a starship to explore the galaxy? And so there are absolutely ideas that have been thought about for this. And so the term is called a Shkadov thruster, or a stellar engine. And what you would do is that you would set up some kind of mirror, some kind of reflecting shape that would be sitting off to the side of the star. And then the star would be pumping out tons of radiation. That material would bounce off of this mirror that you've set up and impart momentum. It would start to push this mirror away. But the mirror would be pulling at the star with its gravity. And so it would be pulling the star with it. And so then you could just kind of move the mirror around in different directions, and the star would follow behind it. And that sounds ridiculous, and it is, but it doesn't violate the laws of physics. And you don't have to make a very big device for you to start to get a thrust if you want. I think there was a paper where they were calculating this, that you could move a spacecraft, you could move a star system tens of thousands of light years in a couple of million years with one of these Shkadov thrusters. And so I think you don't need to turn Jupiter into a red dwarf. You can just build one of these thrusters for the sun. Like, why not just take the solar system with us? And we can just start moving the solar system to other places in the galaxy. And this is one of the arguments for why we don't see any evidence of advanced civilizations out there in the universe, which is, if a civilization has been around for billions of years, then maybe they will have started to build Shkadov thrusters around their stars in their entire galaxy and start to reorganize the galaxy into a form that is more useful to them. That the current structure of the Milky Way is actually very random and disorganized and inefficient. And instead, you could take like this central supermassive black hole, surround that by a ring of other black holes, and then you could have those black holes have rings of stars that are around them, and then those stars could have rings of planets that are around them. So you could reorganize an entire galaxy into a structure that is stable and could then last for a very long period of time, because galaxies are tearing themselves apart. That over deep time, the galaxy is going to shed its stars one by one as they have these three-body interactions with each other. We already have stars that are on escape trajectories leaving the Milky Way. Eventually, the Milky Way will eject every single one of its stars out into deep space. And all that will be left is the supermassive black hole at the heart of it. Or I guess that's all. It will be all alone. It'll be lonely. So there you go. That's your plan. You've got a to-do list. Get to work. It's time to shout out our new patrons at the $5 level and above. Queen Dolina, Darkfinga, Stefan Lentz, Martin Mueller, Boaz Run, Dale Kumreich, Chuck Smith, Miranda Nelson, The Tababito, Mikkel Matthews. Join our community at patreon.com/universetoday. Visto2D, would it be possible to direct a comet into an orbit that hit our moon at fairly low speed? So, would it be possible? Yes. But you got to provide your definition of fairly low speed, that no matter what you do, it is going to hit the moon at tens of kilometers per second. There is no way you're not getting a nuclear bomb like detonation off of the surface of the moon when your comet strikes it. But would it be possible to arrange that kind of crash into the moon? It would be theoretically possible. We did the DART mission that NASA was able to change the orbit of an asteroid a tiny little bit. And so you can imagine either doing some version of the DART mission on a comet to put it into a collision course with the moon, or to have do a series of flybys of the comet with asteroids. You have to change the orbit of an asteroid so it does a close flyby of a comet so that you change its trajectory. But to both have it crash into the moon and have it come in at a reasonable velocity is a big ask. So what you're probably just going to get is this thing crashing into the moon, exploding, vaporizing, and then the debris raining down across the moon. And, one of the possibilities for why we see the permanently shadowed craters at the south pole of the moon that contain water ice is that these are from cometary impacts on the moon, that one of these things crashed into the moon. You got ice, the ice rained down across the entire moon. The stuff that was in the sunlit side, it evaporated, sublimated, but the stuff that landed in those permanently shadowed craters was unaffected by the sun and was able to build up. And now we have billions of years worth of this material showing up. But, if you're hoping to make an atmosphere, that's probably not the best way to go about it. The best way to go about it would be to set up factories on the surface of the moon, solar powered factories where you are taking regolith in, which is, say, silicon oxide, iron oxide, titanium oxide, aluminum oxide, and you are breaking it up into its metal and its waste oxygen, and then you're just releasing that oxygen. And the moon can hold on to an atmosphere. You're going to need to replenish it from time to time, but if you just had great big solar-powered factories that were scooping up regolith, breaking it into rock and gas, you would build up the atmosphere thickness on the moon. And eventually you could get to 1 atmosphere if you wanted to. You just have to build a lot of factories and spend a lot of time. At Skeptic, are ring galaxies the result of a black hole explosion or a collision at the center? Yeah, ring galaxies are the result probably of a collision. So there are these galaxies that look like they've had the center punched out of them. And what has probably happened is at some point in the distant past, another galaxy passed directly through the center of the galaxy. And what it did was it compressed all of the dust in the target galaxy and itself. And so that would lead to a bunch of star formation. It would essentially starve out all of the gas reserves of the galaxy, make it go through its star formation very quickly. And now when you look at it, billions of years later, it is no longer actively producing stars. And so it looks like there's this hole in the middle of the galaxy. There's another kind of sort of a similar object called a jellyfish galaxy. And this is the same thing, where a galaxy has gone through another galaxy and you've got these kind of trailing clouds of dust trailing behind it. And they kind of look like jellyfish tentacles underneath the galaxy. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, how badly did AI hit astronomy jobs? I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank everyone who put your questions into the YouTube comments, everybody who joined me for the live stream. For the next couple of months, we're probably going to be doing the live streams every Monday at 5 p.m. Pacific time to leave the nighttime available for me to try and work on my telescope. But so that's the plan for now. So we didn't do an episode this week just because it was a holiday, but we'll be back on Monday, April 13th. So I'm going to talk about the Artemis mission. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Barry Lee Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bela, Cooper Nelly, Darkfinger, David Gilton, David Matz, Evan.pro, Greg Bealey, James Clark, Janice Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, NordSpace, OneStepForAnimals.org, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Featherman, Team 49, Telescopes Canada, Vlad Chipolin, Wolfgang Klotz, and Zeldabar Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So we are now closing in on a week of the Artemis mission, and it has just been so exciting. And it's funny, people are just coming out of the woodwork and they're asking me questions about the Artemis mission, like regular people that I meet on a daily basis. I was walking outside and my neighbor came by and he just wanted to talk about the Artemis mission and was sort of explaining a bunch of things. And I said, my job is to be a journalist about this kind of thing. It's like, no, I didn't even realize. And so we then talked about space and his excitement. He had watched the original Apollo moon landings. And so he was so excited about the fact that there are astronauts going back to the moon. And a Canadian, obviously all of Canada is pretty excited about this. I'm talking to my dad about it. Even my kids are keeping track of what's going on with the Artemis mission. And it just feels like this is the piece of good news that we need in this time to show you that, in fact, humanity is still really excited about exploration, that, we live in this vast cosmos and we are relegated to our tiny planet. And yet we have the capacity to put 4 people on a rocket and send them on a mission around the moon. For the first time in over 50 years, humanity is going to look down on the moon with their own eyes at close range and just take it all in. And that this is the beginning of this journey that we are making back. So if you're excited about the Artemis missions, it's totally fine. And if you want to have these conversations with everybody around you, I encourage it. And I look forward to their successful return and all of the additional stuff that we're going to learn about this mission. And especially, I'm looking forward to the next one after that, when we see boots on the moon again. All right. We'll see you next time.